For the network shown in the figure with CE unconnected, determine and using appropriate approximations, determine RE, ZI, that is input impedance, output impedance, and your voltage gain. Okay, so there are two conditions. One is CE is unconnected. See, your capacitor CE is not connected to the circuit, so you will be having the effect, or you have to consider the resistor, emitter resistor RE. Second, you can use the appropriate approximations also. Okay, so and if you see your input side, you have a voltage divider biasing. Okay, so step 1, let me try to draw the RE model of the circuit. So first I am going to replace the transistor by its RE model. So you know that in the input side you will be having beta RE, in the output you will be having a current source beta IB in parallel with that of your output resistance R0, right? What will be this point? Emitter. Input will be your base and output will be your collector. Sorry. So you will be having the transistor to be replaced by your RE model. Okay, so now in the input side, what do you have? You have a voltage divider biasing. You have R1, R2. So R1 and R2. And across the emitter, what do you have? You have your resistor RE. Okay, so emitter RE is grounded. So I am connecting R1 and R2 will be also connected to the ground. Across the output, you have your resistor RC. Okay, so this will be your output, and here you will be having your input Vi. So your basic considerations are same. You know the criteria how a circuit has to be converted into its equivalent RE model. Okay, what will be your input impedance? So looking towards the input of the circuit Zi, so looking into the transistor, let me take it as Zb, and output impedance is taken as Z0. Okay, so let me write the equations first. A part, what is your RE? So you know that RE is equal to 26 millivolt divided by capital IE. So if you want to find out IE, you have to go for your DC analysis, right? Yeah. And B part, you have to find out what is your Zi. So what will be your Zi? Zi will be equal to, I am writing it together, R1 parallel to R2 parallel to, what will be your, and what will be Z, R1 parallel to R2 parallel to ZB. Now you have to find out what is your ZB. So if you want to find out what is your ZB, you have to take into consideration the resistor RE also. Okay, emitter bias. So what you will be getting, ZB will be equal to beta into small re plus capital RE, right? So this will be your ZB. So ultimately what will be your ZI? ZI will be equal to R1 parallel to R2 parallel to ZB. You can substitute the value, but here you have to be very careful. You can take the approximations. Okay. Now C part, Z0. So you know that Z0 will be equal to RC, and what will be your D part? AV. AV will be equal to, so what is your voltage gain? Voltage gain will be equal to minus RC divided by RE plus RE, right? Capital RE plus small re. So here also you have to take the approximation. Okay. So since it is a emitter bias, as you have the effect of RE. Okay. So now let's do the problem one by one. Okay, as per the question. So now let's move on to the first part. You have to find out what is your RE. RE is equal to 26 millivolt divided by IE. So if you want to find out IE, you have to go for your DC analysis. So when you go for the DC analysis, you can go with approximation, right? Approximate. analysis. So what will be your condition to be tested? So the condition to be tested is equal to beta Re is greater than 10 times of R2. So what is your beta? 210. What is your Re? 0.68 kilo ohm is greater than 10 into what is your R2? 10 kilo ohm. So 210 into 0.68, you will be getting 142.8 kilo ohm greater than 10 into 10, 100k. Yes, it is satisfying the equation. So it is satisfied. So you can go forward and you can find out the value for IE. So for finding out IE, first what you will do, you will find out the value for VB. So apply voltage division rule. What will be your VB? R2 into VCC divided by R1 plus R2. What is your R2? 10 kilo ohm into what is your VCC? 16 volt divided by what is your R1? 10 kilo ohm plus what is your R2? Sorry, 90 kilo ohm plus 10 kilo ohm. So what you will be getting? 160k divided by 90 plus 10 is equal to 100k, right? So you will be getting 16 divided by 10. Therefore, you will be getting VB is equal to 1.6 volt. Now you have got VB is equal to 1.6 volt. You know this voltage is equal to VBE. Now can you calculate what is your VE? VE is equal to VB minus VBE. So VE is equal to VB minus VBE, which is equal to 1.6 volt minus what is your VBE? 0.7 volt. So you will be getting VE is equal to 0.9 volt, right? So once you have got your VE, you can find out what is your IE. So IE is equal to VE divided by RE. So what will be your VE? VE will be equal to 0.9 volt divided by RE is equal to 0.68 kilo ohm. So what will be your IE? IE is equal to, after solving, you will be getting 1.323 milliampere. So you have got IE is equal to 1.323 milliampere. Now can you finally find out what is your RE? RE is equal to 26 millivolt divided by 1.233 milliampere. So you will be getting, after solving, you will be getting RE is equal to 19.65 ohm. Okay. So it is satisfying the standard condition also. It is the value for RE will be equal to few hundred ohms, right? So first value you have got. Next you have to go forward with your input impedance. So input impedance is equal to, as I have told, let me write it together, R1 parallel to R2 parallel to ZB. So first you are going to calculate what is your ZB. So what will be your ZB? As I have told, ZB will be equal to beta into RE plus capital RE. But you can check the value. Now RE is equal to, what is the value? 19.65 ohm. And what is your RE? RE is equal to 0.68 kilo ohm. Okay, so RE is, capital RE is very much greater than that of RE. So you can use the approximation. You can neglect RE, right? So ZB will be approximately equal to beta into capital RE. Okay, you have got this value. So now the second part is, can I take R1 parallel to R2 as R dash? So R dash is equal to R1 parallel to R2. So we can first find out what is the parallel combination. So what is R1? 90 kilo ohm into what is R2? 10 kilo ohm divided by 90k plus 10k. Okay, so 90 into 900, right? 900 into 10 raised to 6 divided by 90 plus 10, 100 into 10 raised to 3. So here you will be getting 3. So you will be getting it as 9, right? 9k. Is it correct? Yeah, 9k. Now you can do what is meant by, yeah, Zi is equal to R dash parallel to beta into capital RE. So you will be getting, you have to find out what is beta into RE. So beta into RE is equal to 210 into, what is your RE? 0.68K. So you will be getting 210 into 0.68K. It is equal to 142.8K. So R dash is equal to, what will be the value? 9K into 142.8K divided by 9K plus 142.8K, right? So what will be your value you are getting, which will be equal to 9 into, so you will be getting 1285.2 into 10 raised to 6 divided by 9K plus 142, you will be getting 151.8 into 10 raised to 3. So you will be getting Zi will be equal to 8.466K. Zi is equal to 8.46, or you can write it as 8.47K. Now what will be your Z naught? Z naught will be equal to, approximately equal to RC, which is equal to 2.2 kilo. Directly you can write the answer. And D part, now AV is equal to, what is the formula? Taking into consideration your small RE, so R minus RC emitter bias, right? So RE plus capital RE. So you can neglect this RE taking the approximation. So you can write it as minus RC divided by RE. What is your value for RC? RC is equal to 2.2K divided by RE is equal to 0.68K. So you will be getting AV is equal to minus 3.235. So these are your values. So values you will be getting, RE is equal to 19.65 ohm. Zi is equal to 8.47K and Z0 is equal to 2.2K and AV is equal to minus 3.235.